Alright guys, for the second video, we are going to start talking more about interior angles and exterior angles, but instead of just Mrs. O'Brien's lovely voice, you get both myself and
Mrs. O'Brien.
So, tune in, listen up, take out your notes, make sure you are copying things down, and then as we're going through these videos, you need to be looking for a mistake that Mrs. O'Brien or myself will make, and you need to correct it. And we want to see that on Monday. So, first thing we want to talk about are interior angles. So if you take a look at this triangle here, your interior angles are going to be the stuff that is on the inside, hence interior. So we've got one interior angle here, one interior angle here, and one interior angle here. So that means, for a triangle, how many interior angles would there be?
3!
That's right, Mrs. O'Brien, there would be 3. Which leads us right into exterior angles.
So for an exterior angle, what you do is you extend the side of the triangle. So we're going to continue this side all the way. So it makes a continuous straight line. And we're going to do that in the same direction for each one of the angles. So our exterior angles are found on the outside. Exterior, outside. So we have an exterior angle here, an exterior angle here, and an exterior angle here. And if you notice, the exterior angles are also supplementary with the interior angles, and that's going to come up a little bit later. So we've got 1, 2, 3 exterior angles for a triangle. Oops. So here's an example of a triangle. We've got 1, 2, 3 interior angles, and what we're going to do is we are going to rip each one of the angles off the triangle, and we're going to place them so all 3 angles are adjacent. And when you do that, they form a straight line. So this is a rule that we can make up, that the sum of the interior angles of a triangle are 180 degrees, because all of those angles make a straight angle. So this is the triangle sum theorem. This is going to be used over and over, mostly for us algebraically. The sum of the measures of the interior angles of a triangle is 180 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And we need those m in front of the angles because we're talking about the number, the degree the angle is worth, and not the angle itself.
Alright, so now we're going to look at exterior angles. And we take this triangle here, and just like Mrs. O'Brien said, we take and we extend the line out. And what we're going to do then is we're going to cut, it's kind of, I guess, ripping each piece. And notice, if we were to line this up, we've got angle C, B, and A all together. Notice, supplementary, again, which leads us right into the exterior angle theorem, which says the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. That seems like a lot of words, but break it apart. So it says the measure of an exterior angle. All right, the exterior angle we're talking about here is here. So angle BCD. It says that that is equal to the sum of the measures of the 2 non-adjacent. Non-adjacent is incredibly important here. Non-adjacent means not next to. So we're talking about the interior angles A and B. So if we were to write an equation here, we would say the measure of angle BCD equals the measure of the 2 non-adjacent interior angles. So it will equal the measure of angle A plus the measure of angle B. Again, guys, make sure you put the m's in front of the angles because we're talking about the actual number.
So let's take a look at the example. It says find the measure of the exterior angle for angle 1. So So our exterior angle is over here, and Mrs. Venner just went over this. So angle 1, the measure of angle 1, has to equal the sum of the two non-adjacent angles. So angle 1 is touching this angle, so we're not talking about that one. So the two non-adjacent angles are here and here. This one has a box in it, so we know how much that is. That's worth 90 degrees. The other one has an expression, 3x plus 2. The only problem is we don't know how much x is worth. So we're going to have to use the first theorem that we talked about, the triangle sum theorem, that says the sum of all three angles of a triangle has to add up to how much, Mrs. Venner?
180!
So we've got 90 plus x plus 3x plus 2 equals 180 degrees. Or, if you take out that 90 right away by subtracting it, x plus 3x plus 2 equals 90 degrees. So you want to combine like terms and start to get x by itself. So 4x plus 2 equals 90. Subtract 2. So 4x equals 88, which is pretty easy to divide by 4. So x equals 22 degrees. So we're going to plug that in to our measure of angle 1 equation and figure out how big angle 1 is. So 3 times 22 plus 2, so 90 plus 66 plus 2, so left to right, we've got 156 plus 2, so the measure of angle 1 is 158 degrees. Mrs. Venner, is there another way to do this one?
Of course.
There's always more than one way to do it in math. So we found x first. We said x is 22. What do we know again about x and 1?
They're supplementary.
So if we say x plus the measure of angle 1, that has to equal 180 degrees. We know x is 22 degrees. So we substitute that in, substitution property of equality for those of you who still haven't passed your properties quiz.
Which you have to do by Tuesday or it's incomplete.
Subtract 22 from both sides. So the measure of angle 1 equals 158 degrees. All right, let's take a look at another example. Last one.
All right, so here we're finding the values of both x and y. Notice we've got parallel lines here, so we want to use those parallel theorems and postulates that you learned last chapter that you just got
we
tested
still have
on.
to remember that stuff from last chapter?
It's crazy, Mrs. O'Brien.
Oh.
It all builds on each other. It's crazy. So, there's a couple things that I want to be able to put here. First of all, I know that angle 118 and angle x are something special. Mrs. O'Brien, what are those angles?
Are they consecutive interior angles?
Well, are they? Is this angle on the inside of the parallel lines?
No, it's not.
It's not. So they're corresponding angles.
Oh,
And we know that corresponding angles add up to 180 degrees, right, Mrs. O'Brien?
that's totally right.
Obviously. So that means that x has to equal 180 minus 118. So our x must equal 62. Woo. All right, we're doing good so far. All right, now, in order to figure out y, I know that this angle, this exterior angle, and this angle, this interior angle here, are supplementary and they add up to 180 degrees. So I can figure out what this angle is right here by taking 180 minus 62. And that gives me 118. All right, so that inside interior angle there is 118 degrees. Now we can use the triangle sum theorem and say that if we add 118 degrees plus 22 degrees plus my last interior angle, which is y, that's going to equal 180 degrees. All right, we do some simplification here. Remember, left to right. So we've got 140 plus y equals 180. We're going to subtract 140 to the other side. So y must equal 40 degrees.
Wait a minute, Mrs. Venner. Something's wrong. That doesn't look right.
What could we have done wrong, Mrs. O'Brien?
I don't know. Let's do this again.
All right.
All right. You said 118 is that angle.
Yes.
We got to figure out what x is. What kind of angles did we say x and 118 were?
I think we said corresponding.
Corresponding angles don't add up to 180.
Oh, they're congruent.
They're congruent.
That's right.
That's what it is. So x is 118 degrees. So now let's do the exact same thing that you did. The exterior and the interior angle have to be 180. But wait, we don't even have to do that, Mrs. Venner.
Why not?
Because we know the exterior angle has to equal the sum of the two non-adjacent angles.
Mrs. O'Brien, you're so right.
So 118 degrees instead of x has to equal y plus 22. So let's subtract 22 from both sides. So y equals, what is that, 96?
That would be.
All right, so y is 96 degrees.
But Mrs. O'Brien, could I have done it the other way if I would have gotten that the corresponding angles were congruent? Could I have done it the other way too?
What way?
With the triangle sum theorem?
Oh, yeah, you could have too.
Oh, okay.
It's Friday. So 180 degrees minus 118 leaves us with how much?
62.
62. So this is 62 degrees, our green angle. We know the blue one is 22. So 62 plus 22 plus y better equal 180 degrees. Why not do it both ways and double check your answer?
Absolutely.
So we've got 84 plus y equals 180. Subtract 84 from both sides, and y equals 96 degrees. What a good check. All right, guys, we're going to double check your notes on Monday to make sure you guys have everything that you need. So please make sure you took really good notes. And if you didn't, watch the video again and take your notes.
Have a fantastic weekend, and we'll see you on Monday.
All right.